Versatile and feature-rich, ProSense PPC5 advanced process controllers available from Automation Direct are the premier choice for any application where precision and reliability matter. They accept inputs directly from thermocouples or RTDs or analog signals from practically any sensor or transmitter and use those inputs to deliver a wide variety of control modes, functions, and alarm types for just about any process variable control application. One of the features offered in several models is Modbus communication. RTU serial over RS485 or Ethernet TCP. Using this communication ability, a controller like a PLC, a PC, or an HMI can change remote settings or send a custom scrolling message to be displayed on the PPC5. At AutomationDirect.com, on the product pages for these process controllers, you'll find some example programs for Automation Direct's PLC lines that make implementing these features a snap. You can also find a link to these programs in the description below. Download and unzip the file. We're going to go through using these programs with a couple of different Automation Direct PLC platforms. Let's start off with a process controller that is powered up and that has been set up at least with the Quick Start process that displays on the initial boot up of the PPC5. See the Quick Start guide that was packaged with the controller or the user manual available at AutomationDirect.com, also linked in the description below. For this demonstration, we'll be using Ethernet communications for which the example programs are configured. We'll be using a PPC5-1102 model controller. The PPC5-1002 is also equipped for Ethernet comms and could be used with these instructions as well. Before we get to any communication, the PPC5 will need to have its COM port configured to put it in the same subnet as the PLC. All of the example PLC programs will attempt communication with the IP address 192.168.1.40. So that's what we'll program into the PPC5, and we'll set that up through the controller's face. Hold down the parameter and left arrow button at the same time. Navigate over to the Ethernet menu. Select and change the parameters IP1 through IP4 to set the IP address to 192.168.1.40. Once the 4 octets of the IP address have been entered, toggle the ESW to on and back to off. This writes the values that you just entered into the IP address. Note that until you complete this, the settings will not have changed. First, we'll take a look at using communications to set a remote set point. It's as easy as writing your desired value to the PPC5's remote set point address. In this case, we'll demonstrate with the Click PLC. You'll need to have the Click programming software installed on your computer to follow along. The software for all of Automation Direct's PLC platforms can be found and freely downloaded on our web store at www.automationdirect.com/support/software-downloads. Or again, find a link down in the description. Run the Click programming software. Open an existing project. Navigate to the extracted ProSense PPC5_example programs folder. Find the Click folder and then the remote setpoint folder. Select the ProSense PPC5_remote setpoint.ckp. As we mentioned, the PLC will be using Modbus to send instructions to the PPC5. If you're deploying a process controller, I would say odds are better than even that you're already familiar with this protocol, but if not, don't worry. These example programs handle all of that, and the run comment documentation does a really good job of letting you know what is going on. For now, let it suffice to say that Modbus will allow the master device, in this case our Click, to write values to specific addressed registers in the slave device, our PPC5. On rung 4 of the Click code here, we see a Modbus send instruction, which, when bit C2 is true, is sending the value of DS3, 1 set up in rung 3, to Modbus register 402701 in the PPC5. This is the register for parameter RMS_L1, the remote input method for loop 1. We're telling the process controller to take its loop 1 set point via Modbus communication. The next couple of rungs send values to both the local and remote set points for loop 1. In rung 7, whenever the PLC bit C1 changes state, that state is sent to the PPC5's local remote switch, toggling its loop 1 set point between local and remote set point values. In rung 8, notice this is a Modbus receive or read instruction rather than a send. We're pulling the PV value for loop 1 and writing that into the PLC's DS4. In each rung here, we are writing or reading from a specific Modbus register within the PPC5. Where do we come up with these register addresses? You'll find all of the parameter addressing information in the user manual we mentioned earlier, in chapters 23 and 24. Let's take a look at this program in action. In the Click software, go to the PLC tab and connect. Assuming your networking is all set up correctly between your PC and your PLC, you'll go online with the PLC. Open Data View 1 in the navigation window on the left side of your screen and you'll see all the bits and integers we need to monitor and/or control. Turn on C2 to set the remote input method as we touched on before. C3 will write the value in DS1 into the PPC5's local setpoint for loop 1. C4 writes the value in DS2 to the remote setpoint. Toggling C1 will toggle the PPC5 between the two setpoints. And when C5 is true, the PLC will read the process variable from the process controller. Let's take a look at writing a scrolling display message to the PPC5, this time using a productivity PLC. Run the Productivity Suite programming software and open the ProSense PPC5 Example Programs Productivity Display Message. Run the ProSense PPC5 message program. Click the Choose CPU button, click Connect, and transfer the project to the PLC. Of course, you'll need the PLC's IP address to be in the same subnet and all of that networking stuff, just as before. The productivity environment is somewhat different than that of the Click, but essentially we're doing the same thing here, using Modbus write commands to move data into specific registers in the PPC5. Open a data view. There are two tabs already created. On the first tab, you'll see that the user entry _ message comes already filled with Hello World. The reason for this is that programmers just can't help themselves. Let's change that to something we might be more likely to see in a deployed system somewhere. Say, a notification that the system is currently down for maintenance. In the user entry _ message edit column, keeping in mind that there's a 20-character limit for these messages, enter down for maint and click the right icon to load it into the PLC. The value column should now match the edit column. Next, we'll write the new message string from the PLC into the PPC5. Click the Load New Message Edit checkbox and click the Write button. The message is now stored in the PPC5. The message on the PPC5 is toggled on and off by a trigger bit that we can assign. In our case, we want the trigger to be PPC5's internal bit M01. Check the Edit box in the Assign Trigger M01 row. Click the Write button. Now we can toggle the message display on and off by writing to the M01 bit with the Show Hide Message bit in the PLC. Check the Edit box and write. The message will start scrolling. Uncheck, write, and the message will stop. Remote communication is just one of the many outstanding features of the ProSense PPC5 Advanced Process Controllers. Check them out today at AutomationDirect.com. To see an overview of the PPC5 controllers, click here. To see more process control products, click here. To subscribe to our YouTube channel, click here.